Hello, and welcome to another riveting episode of Camel Essentials. Today we're going to talk about how to do routing and the route builder and just basic concepts around the route. So without further ado, let's get after it. Okay, first let's talk about what we're going to cover today. So today is going to be about creating routes, initializing the routes using Spring Blueprint, how to define it both using Java and XML, how to look at the multi-threading in there, things like that. So it should be fairly in-depth, but we'll try to make it quick so you get as much information in a short amount of time as possible. All right, so to understand a route, you have to understand the basic concepts of a route. So when you're creating it, you have these certain containers. Basically, you have the CamelContext that will house basically everything about your Camel routes. And then you've got the route builder, which is what you use to construct your routes. And then you have the routes themselves. Okay, first thing we're going to look at is the route structure. So in this example, we have a route order that extends a route builder. So that's kind of the structure you're going to have to do, because in order for you to build a route, you've got to extend the route builder. That will force you to override the configuration. Once you have a configure method in here, now you can go ahead and build your routes within that configure. It's important to identify the route, because if you don't, within like JMX, you just get these basic route 1, route 2, they're very generic. If you identify it, it's going to be easier for you to work with, both from a testing perspective, but also from an identification and monitoring and everything else. If you want to start and stop routes later on, you really want to name your routes. And then in this case here, we're just using some components to read from a file and then to send it to a direct. The other piece to understand is that once you've got your route builder configured, now you have to add it to the CamelContext. So you can do stuff like this in code, or you can use Spring to do it too. And Spring will auto wire some of this together for you. So the life cycle of a route is fairly generic. You've got the start, stop, you can suspend it, you can resume it, and you can remove it. These are all very powerful, especially when you're inside of a console, something like a Carafe console or something like that, where you have access to the CamelContext and you can actually write commands that will start and stop basic Camel routes without ever having to start and stop a container, restarting containers, things like that. So it makes it very useful and powerful from being able to manage a CamelContext from within a console of some sort. And in some cases, I refer to Carafe, but anytime you have access to the JMX endpoint, you can even do this from the JVM, from a visual VM, or what's another one? JConsole. That's it. So you can also do this from JConsole. When we start looking at Camel routes, being able to start and stop routes, you can do this from within code, you can do this from in JConsole, you can do this from pretty much anywhere that supports access to the context. So here what you see is we have the ability to start a route, and this is where identifying your route or IDing your route is very, very important. So here we can start the route, stop a route, remove a route, suspend a route. Surprise, surprise, it's usually pretty easy to tell what you're doing based on the method call. So if you're now once you have, or let's say you want to be able to now initialize. Okay, let's go ahead and initialize the routes now. So we can use Spring as an example here. We can define specifically the bean for the route order, and in this class you can see I've specifically started a bean called my order routing, and then we've done that within the route builder of the CamelContext. You can also use different annotations. There's lots of different ways that you can kind of define these. These are just a couple. Again, you can do a package scan where you're telling it, here's my CamelContext within Spring, and I'm gonna, this is my package name that has all my routes in it and defined. It will scan it and find all the CamelContext or all of the Camel routes, and initialize them. If you're doing this in XML and you don't want to write code in Java, you can also do that. So here's an example of being able to define your routes directly within the XML. Now, to me, this is a lot less powerful. There's a lot more nuance to it, and it's kind of verbose. But again, doesn't, if you're familiar with XML and you're more comfortable in an XML world, this is your bread and butter. Great. This is you can use this. I personally prefer not to. If we're going to look at how you can let's take a look at initializing just some of the beans and how it starts and stops and disposes of specific content within your route. Next, let's take a look at how we might initialize a bean or destroy a bean. Reasons you might do some of these things would be, validating input, ensuring that your connections are created and initialized correctly, that you can error out of your camel routes if for some reason something doesn't initialize correctly, and that way you can give proper errors and their handling. Also, with this disposal of it, you want to be able to close out AMQ connections or JDBC connections, ensuring that you can release resources back to the container. So all of this is extremely important when you're either starting up and creating camel routes, or if you're shutting down and disposing of them. Let's take a look at how we might do something like this. So from the concept of within the Java DSL, you have the order router. So you can implement initialize bean and disposal of beans. And now you have the methods of after property set and destroy. This gives you a lot more power to be able to log things, give better error handling, understanding what happened during initialization and what's going on during shutdown if you want to close connection, things like that, which is very important when you start and stop these camel routes. Another very powerful aspect of Camel is to be able to multi-thread a route. So this can speed up and slow down your processes dramatically based on how you utilize it. So if you're just using a single-threaded, single consumer route against an JMS endpoint, and in this case we're talking about a message queue, and you've got a JMS component and it's working against the queue, it initializes that one consumer, has a single route, and what that allows it to do then is say, okay, I'm going to push the message all the way through on a single thread. Or you can do things like in only, and that will say push the message to the first process, and that will then in turn generate a new thread for each and every process down the line. So there's a lot of power here in how you do some of this stuff, especially with asynchronous versus synchronous. When you wanted to acknowledge the message back in ActiveMQ, there's so much power here. You have just about an infinite number of ways of configuring some of this. But if you stick with the out-of-the-box kind of functionality, whether you're synchronous and that creates a single thread all the way through to the end of your route, or if you're asynchronous and you just, the first consumer or the consumer itself and the first processor is basically what is the thread that's consuming, and then it pushes it off to another thread. These are all very important concepts to understand. But let's say you want to multi-thread and from the endpoints, you want to create multiple consumers. You can do that as well. So in this case, this kind of demonstrates how you might take a single queue and have competing consumers against it. That's basically what this is. So all of these routes are getting a separate message, and they're all consuming at the same time. They're consuming concurrently, right? So each consumer will execute on their own route, and they'll execute independently of each other. It's very important to understand that each route in that's defined here will get a different message. So route 1 will get a message. This, let's say this is route 1A gets a message and route 1B gets a message. That's what this indicates. So that gives you a lot of throughput capabilities as you start multi-threading this out. Let's say it's a single message. I don't want to confuse this too much, but let's say you've got a single message that comes in, and with that single message, you've got a fast process that does something against it. Let's say you're just writing it out to Cassandra or something like that, very quick. And then you know that you've got like an HTTP call to a third-party client that's really slow, that takes seconds to run. And you know this is going to be slow, and you want to multi-thread it. That's assuming you don't have throttling issues with your third-party client. But let's just say that this is a slow process that you can multi-thread and you can hit it with not as many as you want, but a lot more. So in that case, you can read off the queue, do your fast processing, and then you can thread the route from that point forward. And in this case, as you can see, what ends up happening is it'll read a single message from a queue, send it to that process, and then it'll multi-thread it out. So it'll start pushing more data across to these other threads. So it'll run faster. So that's an important concept to understand, is that you don't necessarily always have to be running with multiple threads from the start. You can multi-thread it at any point in your route that makes sense. How do you do some of this? Well, let's take a look at the thread pooling. So in this case, there's multiple different functions in here that allow you to specify the thread count as well as the core size and the max size. What that basically means is, here's the threads. We're gonna start with, let's say, well, in this case, 3. We don't want it to go below 2. If things slow down or things like that, we always want to keep 2 threads that are warmed up, ready to go. But we also don't want it to rise above, let's say, 5. Let's say you have only a certain number of threads, certain number of cores on the CPU. You want to make sure that you're not just exploding this out. So in this case, let's say we've got 5 as a max. That's our thread pooling configuration. And then there's other pool properties that you can specify, like how long you want to keep it alive, if the thread is idle for a certain amount of time, what's your reject policy, things like that. You have a lot of flexibility here. That's the cool part. And one of the last pieces I want to touch on is just logging, because it's very important to understand how you can utilize logs, especially when you're trying to monitor or just understand what's going on within your Camel routes specifically. So you can use log4j, logback, comment jogging, SLF4j. You can do things like show all, show exchange, show headers. These are just some of the kind of built-in concepts around the logging component. There's a lot of ways to write out content. Camel expands pretty much daily, it feels like. So there's a lot of different ways to do this. But I'm just going to show you some of the basics. So in this case, we have different levels: info, debug, trace, marker, the normal stuff you're used to doing logs. The interesting part is when you start looking at some of the group intervals, group size, delays, how you want to log things out, which is very helpful when you're doing things like this, where you want to actually kind of see logs at a statistical level. Something like this, where you've got the ability to do intervals and you can see how many messages went through it so many times. Now, this is important if you have high volume. If you're really pounding this thing a lot, these kinds of log level metrics can be very important and be very useful. So that does it for today. I hope you found this video informative, helpful, and we'll see you on the next one.